Okay, so the device I'm going to be using today is an electric guitar. This is my brother's guitar, and I don't know how to play it, so I can't play any cool songs for y'all, but I can tell you guys about the instrument and how it uses Physics 2 principles to work. So first, a quick introduction. The electric guitar is one of the most iconic musical instruments of the modern era. It was originally developed in the 1930s. The electric guitar was made to enable new genres like rock, jazz, blues, and metal to break past the volume limitations of acoustic instruments and introduce an entire new world of tones and effects. Unlike a regular acoustic guitar, which relies on the natural vibration of wood to produce sound, an electric guitar uses electronic components and, more importantly, Physics 2 principles to turn mechanical energy into an amplified sound. So the first principle I'm going to go through is Faraday's law. Faraday's law essentially means changing magnetic flux through a coil induces an EMF or voltage in that coil. So if you change the magnetic field in the coil, you'll get electricity. So when this guitar is unplugged, the pickups, these things right here, they still work and still play a tune. Sounds a little familiar to a regular guitar, but when it isn't connected to an amplifier, which is this little thing right here, the induced voltage has nowhere to go and is incredibly weak, so you won't really hear the sound being amplified. Now, if I was to plug this in, which I'm going to do for y'all. Okay. I gotta turn it on. Now that signal is amplified. So the amplifier takes that small voltage that was generated via Faraday's law and boosts it so you can actually hear it through a speaker. Now real quick, while I have it plugged in, I'm going to tell you guys about Ohm's law. So Ohm's law is the relationship between voltage, current, and resistance in an electrical circuit. And the thing about an electric guitar is it has circuitry inside of it. Same thing with the amp over here. So that voltage drives a small current through the input circuit of the amplifier. So if I was to strum this and mess with the volume, you can hear it getting louder and smaller, or quieter. So that is just another principle that is being put into application when using an electric guitar. Alrighty, so now I'm going to tell you guys about magnetic flux, because that is also used with an electric guitar. So magnetic flux refers to the total magnetic field that passes through a given area. It's a way of measuring the strength and extent of a magnetic field over a surface. Now these pickups, these two black things right here that I mentioned earlier, they typically consist of a magnet wrapped in coils of wire, and these wires are typically right here, usually made out of copper. And the magnet creates a magnetic field around the guitar strings, which are normally made of steel or nickel. So when a guitar string vibrates, it disturbs the magnetic field around the pickup. This disturbance changes the magnetic flux through the coil, and the induced voltage creates an electric current that mirrors the vibration pattern of the strings. Alrighty, now next I'm going to talk about frequency. So frequency refers to how often something repeats over time, typically in the context of waves and vibrations. Frequency tells us how many cycles per second a wave completes. Typically, higher frequency means more cycles per second, which in the case of the guitar, typically means a higher pitch of sound. And the electric guitar is basically a sound wave generator. So when I pluck a string, it vibrates at a fundamental frequency that is determined by the string's length. So this right here is a lot longer than this. It travels down here. So that's a portion of frequency. Tension, these strings, or this one right here, can't quite move it as much. These ones I can move a lot more. And that is why you can hear this as a higher note and this as a lower note. Alrighty, and the pitch you hear is directly related to the string's vibration frequency. Now, last thing I'm going to show y'all, back to these pickups. Again, I can move these more freely and they are closer to the pickups, so they make a certain sound. But then if I was to pluck these up here, all this tension, and it's further away from the pickups, it sounds completely different.